Hello everyone. In this video we are going to consider the first part of the course Introduction to Biostatistics or Statistics in general. So in this video we are going to look at the definition of a variable and the types of variables based on the values that they assume. So a variable is a characteristic or an attribute that can assume different values, and here when you say different values, the characteristics or the attribute should assume a minimum of two values to be identified as a variable. For example, if you consider the height of an object, it could be 1.6 meter, 1.7 meter, 1.5 meter. Then height assumes different values, therefore it is a variable. Similarly, if we consider family size, it could assume values 1, 2, 7, 4, 6, and so on. Then family size also assumes different values, then it can be considered as a variable. Similarly, if we consider gender, taking the values male and female, then gender assumes two different values, then gender is also a variable. And the same is true for marital status, if it assumes, let's say, single, married, divorced, and other. Therefore, marital status assumes four different values for this particular example, then it is also a variable. Therefore, any characteristics or an attribute that can assume at least two different values, or any characteristics or an attribute whose values vary from object to object or from individual to individual is said to be a variable. Now, if we look at these four variables, they have some difference. Especially height and family size assume numeric values, gender and marital status assume non-numeric values. Then, based on the values that the variables assume, they can be classified into two as quantitative and qualitative or categorical. The quantitative variables are those variables which assume numeric values in nature. You can consider height and family size. Height and family size are numeric in nature, or they assume a numeric value by nature. That means the values of these variables cannot be non-numeric. Therefore, height and family size are quantitative variables. And if we consider the second category, which are qualitative variables, these variables assume non-numeric values, which are usually called categories, levels, or groups. For example, if we consider sex, sex assumes values male and female. Then sex has two categories, and these two categories are non-numeric values. Therefore, sex is a qualitative variable. Similarly, if we consider marital status assumes values single, married, divorced, and other for this particular example. Therefore, marital status is also a qualitative variable. So here we can say, instead of saying a value for those qualitative variables, we can call it as categories, levels, or groups. So sex has two categories, male and female, two levels, or two groups. Similarly, we can say marital status has four categories, four levels, or four groups. Therefore, these qualitative variables assume non-numeric values. For the purpose of statistical analysis, the categories may be coded, but even if the categories are coded, these variables are still qualitative. So, for example, for sex, we may use the code 1 for male, 2 for female. Then sex assumes two values, 1 and 2. Even if sex assumes these two numeric values, sex is by nature a qualitative variable. Therefore, the only purpose of the numbers is identification. But when you come to that of the quantitative variables, they assume numeric values in nature. Therefore, their values cannot be something different from a number. Height should assume a number, family size should assume a number. Therefore, both of these variables are quantitative variables. Now, if we consider the quantitative variables, we can observe that height can assume any values, including decimals, and family size assumes only whole number values, or values that can be obtained by counting. Then again, based on the values that the quantitative variables assume, they may be classified into two. Therefore, a quantitative variable can be discrete or a quantitative variable can be continuous. The discrete variables are those quantitative variables which assume whole number values. For example, family size assumes whole number values. Number of children in a family assumes whole number values. Mother's history of the number of births or parity assumes whole number values. Number of infections in a certain area assumes whole number values, and number of hospital admissions also assume whole number values. Therefore, these variables are discrete variables. Therefore, the values of these variables are obtained by counting, like 0, 1, 2, 3, and so on. And in general, these discrete variables may assume a finite number of values, or even they may assume a countably infinite number of values. Therefore, the discrete variables, even if they assume infinite number of values, their values are countable. Therefore, as long as the values are countable, those quantitative variables whose values are countable are called discrete variables. And the second classification of the quantitative variables is continuous variables. These continuous variables are those quantitative variables again, but these continuous variables take any value, including decimals. And theoretically, these continuous variables can assume an infinite number of values, and these infinite number of values are uncountable. Therefore, here the values of the continuous variables are obtained by measuring. For example, you can consider height, weight, time, temperature. If we want to know the value of the height of an object, we need to measure. Therefore, the values of the continuous variables are obtained by measuring, and the values of the discrete variables are obtained by counting. Now let's go to that of the qualitative variables. Again, if we go back to the previous slide, here sex assumes values male and female, and marital status assumes values single, married, divorced, other. Now, based on the number of values, a variable may assume only two values, like sex, which is called binary, or a variable, specifically a qualitative variable, may assume values more than two, let's say, or categories more than two, like marital status. Therefore, based on the number of values that the qualitative variables assume, they may be classified into binary or dichotomous, and multinomial or polytomous. The binary variables are those qualitative variables which assume only two values, or the binary variables consist of either or type of responses. Therefore, for sex, for example, we have either female or male. Therefore, binary variables are qualitative variables which assume either or type of responses. So here these binary variables have only two categories or levels or groups. Sex, it could assume female, male. Sex is a binary variable. Patient status, cured, not cured. Patient status is now a binary variable. Pregnancy status, pregnant or not pregnant. Again, pregnancy status is a binary variable. Exam result of a student, pass or fail. Again, this variable can be considered as a binary variable. And similarly, smoking status, smoker or non-smoker, it can be considered as a binary variable. And the second classification for the qualitative variables is multinomial variables. The multinomial variables are those qualitative variables which assume three or more categories or more than two categories. For example, the Blur group of an individual, it could assume either A or B or AB or O. Therefore, Blur group or Blur type of an individual is a multinomial variable. Marital status, assuming values single, married, divorced, other. Now marital status is a multinomial variable. Similarly, you can consider religion, color, and so on. Any qualitative variable assuming three or more categories is called a multinomial variable. In general, in the definition we have said that a variable is any characteristics that can assume different values, or a variable is nothing but a characteristics that can assume at least two different values. But if a characteristics assumes only one value in a particular study, that characteristics cannot be considered as a variable. Rather, that is a constant. For example, marital status, by definition, it is a variable. But marital status will not be considered as a variable if all the participants are married. Similarly, sex by definition it is a variable because it may assume male or female. But sex would not be considered as a variable if all the participants in a study are female. Therefore, a concept or a characteristics assuming only one value in a particular study cannot be considered as a variable. Rather, the characteristics should assume a minimum of two different values. So this is the different types of variables. Here are examples to identify the types of the variables like color of automobiles, age of patients, number of seats, blood pressure, the distance between a house and a hospital, classification of patients based on nursing care needed, temperature in a classroom, number of tomatoes on each plant on a field, weight of newly born babies in a hospital, number of heart attacks, temperature. So you can pause the video and try to identify the types of these variables, whether each variable is quantitative or qualitative. If quantitative, whether the variable is discrete or continuous, and if the variable is qualitative, try to identify whether the variable is binary or multinomial. So this is all about today's video. Thank you.